What if there was a structural feature baked right into the walls of your home that could drop your indoor temperature by 15 degrees Fahrenheit in the dead of summer, with no fan, no compressor, and zero electricity? While the building industry keeps selling you on mechanical HVAC systems that lose efficiency every year and cost you more every season, this technology transforms the structure of your house into its own cooling engine. It harnesses the weight of air and the laws of thermodynamics to generate a constant, quiet flow of fresh ventilation, one that flushes out pollutants, stops mold before it starts, and cuts your dependence on the power grid entirely. And yet, despite being one of the most cost-effective and time-tested cooling solutions ever devised by human beings, this technology has been deliberately pushed aside by an industry that profits from airtight, energy-hungry buildings that need a machine running 24/7 to stay livable. So, what is this technology? How exactly does it work? And why doesn't anyone talk about it? Let's break it all down. To really appreciate why the solar chimney is so remarkable, you have to understand the conditions that forced its invention. This was never an aesthetic choice. It was survival engineering. The story starts roughly 3,000 years ago on the scorched desert plateaus of ancient Persia, in cities like Yazd, where summer temperatures routinely climbed past 113 degrees Fahrenheit. The architects of that era had no electricity, no chemical refrigerants, and no mechanical compressors. What they did have was a deep working knowledge of how air behaves under heat. Their solution was the bad gear, a tall masonry tower that used the thermal properties of dense stone to drive airflow. These weren't ornamental structures. They were functional thermal engines, exploiting the pressure difference between shaded interior courtyards and the sun-baked surface at the top of the tower to create a continuous thermal siphon. In many cases, the towers worked alongside qanats, underground water channels, so that incoming air was drawn across cool water before entering the living space, adding evaporative cooling on top of the convective movement. For centuries, this was the gold standard for keeping buildings habitable in extreme heat. When the British Empire expanded into hot climate regions like India and Africa in the 19th century, they encountered these systems and began incorporating them into military barracks and colonial hospitals. Documentation in the British Medical Journal from that era noted that hospital wards ventilated by thermal stacks had considerably lower death rates during cholera and influenza outbreaks. The reason had nothing to do with medicine. It was physics. The stacks continuously flushed the air in those rooms, removing the pathogens and moisture that accumulate in stagnant, sealed spaces. The reason a solar chimney outperforms a mechanical fan has nothing to do with power output. It comes down to the stack effect and the Bernoulli principle. Here's what happens inside the system. A solar chimney is essentially a vertical shaft engineered to capture as much solar energy as possible. At its heart is an absorber plate, typically a dark-coated metal or masonry surface, set behind a layer of high-transmittance glass. Sunlight passes through the glazing, strikes the absorber, and gets converted into radiant heat. Per the ideal gas law, that heat lowers the density of the air inside the shaft. Lighter, energized air rises and exits through the exhaust at the top. That upward rush creates a zone of negative pressure at the chimney's base. Nature won't allow a vacuum to persist, so the building is forced to pull in replacement air, drawing it from the coolest, most shaded part of the structure, whether that's a north-facing intake vent or an underground earth tube. That fresh air travels through the living space before getting pulled up and out by the chimney. Here's the elegant part. The system is self-regulating. On a 100-degree afternoon, when a conventional AC unit is drawing its maximum current and working hardest to keep up, the solar chimney is also at peak performance. The greater the temperature differential between the collector and the surrounding air, the faster it moves air, potentially thousands of cubic feet per hour, all without a single moving part. This is where smart design makes the difference. A properly engineered solar chimney includes a bypass damper system. When temperatures drop, you close the exterior exhaust and redirect the rising heated air back into the building's thermal mass through an interior return vent. At that point, your cooling tower becomes a passive solar air heater. Same structure, opposite function, no additional hardware needed. The performance of these systems has been documented extensively. In 1995, researchers at the University of Arizona conducted a detailed study of a residential solar chimney installation in the Sonoran Desert. The results? The system held indoor temperatures at 75 degrees Fahrenheit, while the outdoor air sat at 106 degrees. That's a 17-degree reduction using nothing but sunlight and atmospheric pressure. Air quality tells an equally compelling story. The EPA estimates that indoor air is frequently 2 to 5 times more contaminated than the air outside. In a modern sealed home with a standard HVAC system, most of the air circulating is simply being recirculated, delivering less than half an air change per hour of genuinely fresh air. That stagnation allows volatile organic compounds, CO2, and moisture to build up over time, contributing to what researchers call sick building syndrome. A solar chimney, by contrast, delivers between 8 and 12 complete air changes per hour, all fresh, filtered outdoor air. It's the equivalent of leaving every window in your house wide open, without the security risk or the loss of temperature control. Over its 15-year lifespan, a standard 3-ton central air conditioning system, including manufacturing, installation, and operation, carries a carbon footprint of roughly 25 tons of CO2. A solar chimney, built from high-mass masonry, recycled aluminum, and glass reaches carbon payback in under 6 months. After that, operating costs are zero. It's a permanent structural feature that reduces your monthly overhead while increasing the value of your property. A University of Nottingham study found that buildings using solar chimney systems could cut their total cooling energy consumption by up to 75%. In an era of climbing energy rates and an increasingly unstable grid, that level of independence is something no mechanical system can offer. The answer isn't complicated, it's just inconvenient. The modern construction industry is built around standardization and subcontracting. It's far simpler for a developer to throw up a cheap, poorly insulated box and hand it off to an HVAC contractor for a $5,000 mechanical fix. There's no need for specialized architectural knowledge or integrated design. It's fast, it's predictable, and it generates repeat business. Energy companies and HVAC manufacturers have no financial interest in a technology that installs once, runs indefinitely, never needs a service call, and sends no monthly bill. The incentive structure is entirely aligned against it. The regulatory framework does the rest. The International Residential Code doesn't explicitly prohibit solar chimneys, but it's built almost entirely around ASHRAE 62.2 standards that assume mechanical ventilation inputs. Because a solar chimney is passive, its output varies with solar intensity rather than following a fixed performance spec. It doesn't qualify for a UL listing or an Energy Star certification. It can't be rated the way a product can because it's not a product. It's a feature of the building itself. Most building inspectors, unfamiliar with the technology, will require a mechanical backup system as a condition of approval. That requirement doubles the build cost and forces homeowners to purchase equipment they don't need. It's a bureaucratic veto dressed up as code compliance. We've been told that active systems with compressors and refrigerants represent modern progress, while passive systems like the solar chimney are relics of a primitive era. The reality is exactly backwards. The mechanical system is the crude solution, brute force energy consumption powering components that are designed to degrade and eventually fail. The chimney is the sophisticated solution, built on a permanent and elegant understanding of physical law. There are two main approaches depending on whether you're retrofitting an existing structure or starting from scratch. For an existing home, the most practical option is a wall-mounted solar chimney, an insulated collector box attached to a south-facing exterior wall. You'll need an absorber plate coated with a selective surface finish, a material that absorbs around 95% of incoming solar radiation while minimizing re-emission of that heat back through the glass. Cover the collector with low-emissivity glazing to retain the heat inside the shaft. For a 500 square foot space, a collector area of roughly 20 square feet is sufficient. A DIY build using UV-stable polycarbonate and high-temperature silicone typically runs $300 or less. Cut 2 6-inch vents into your wall, one near the floor, one near the ceiling, and the physics handle everything else. For new construction, you have the opportunity to design the entire building as an integrated atmospheric engine. That means incorporating vertical shafts 20 to 33 feet in height into the south-facing thermal mass of the structure, lined with spectrally selective absorber plates and shielded by low-iron, high-transmittance glazing. Position your air intake at the lowest, most shaded point of the building. The chimney creates a continuous pressure gradient that draws geothermally tempered air in at floor level and expels hot, buoyant air through roof-level exhaust vents, 0 watts, 8 to 12 air changes per hour. If you want to push the system even further, pair the chimney with an earth tube. Run 100 feet of 6-inch PVC or clay pipe at a depth of around 6 feet underground, where soil temperature remains a stable 54 degrees Fahrenheit year-round. The suction generated by the solar chimney pulls fresh air through that buried tube. By the time it enters your living space, it's been passively cooled to approximately 70 degrees. That's a 0-watt air conditioner, one that keeps functioning even during a complete grid failure. Because there are no motors, refrigerants, or moving components of any kind, the system essentially maintains itself. Once a year, check the intake filters to ensure unrestricted airflow and clean the glazing surface to maximize solar transmittance. Compare that to the annual $200+ service calls, filter replacements, and refrigerant recharges a mechanical system demands year after year. The solar chimney isn't an appliance. It's a permanent organ of the building. The solar chimney is a 3,000-year-old answer that still outperforms the machines we've spent a century building to replace it. It requires no grid connection, no utility contract, and no subscription to a cycle of planned obsolescence. It works because physics works, and physics doesn't issue invoices. This technology wasn't abandoned because it stopped working. It was sidelined because simplicity doesn't generate recurring revenue. If you're serious about reclaiming control over your home's energy and comfort, the answer might already be written in the laws of thermodynamics. You just have to build it. And if the solar chimney caught your attention, wait until you see what a trombe wall can do. Same thermal mass logic applied to your walls, capable of slashing your heating bills by up to 70%. That video is next.